Okay, let's quickly review the three from the sheet that were still left that I'd asked you to finish. Number 13 says you're pushing a shopping cart filled with groceries across the parking lot at the superstore. The cart's mass is 134 kilograms, and you push with a force of 300 newtons downward at an angle of 36.87 degrees. You start with the cart at rest and reach a speed of 7.746 meters per second after covering 60 meters. What must the coefficient of friction be? So first from this you can get A from Vf squared equals Vi squared plus 2A delta D, right? That goes to 0, square the 7A will be equal to Vf squared over 2 delta D. And I think I picked the numbers as such, it ends up as 60 point something on the top and 2 times 60 on the bottom. And so you get your A to be 0.5 meters per second squared. Okay, so then you go to sum of the forces. Sum of the forces in the y direction, MAY will be 0. So it'll be Fn going up, Fg going down, and Fy going down. So Fn will be equal to mg, comes positive, take the Fy over, and it becomes positive F sine theta. Go to sum of the forces in the x direction, and it'll be Fx minus friction equals max. Fx is F cos theta. Friction is mu Fn is equal to max. I take the mu Fn over and the max over, so because you're trying to solve for mu. So F cos theta minus max is equal to mu brackets, what you have here, mg plus F sine theta. And now divide both sides by the brackets. So mu is equal to F cos theta minus max over mg plus F sine theta. And now fill in your numbers. So mu is equal to F was 300 newtons, cos of 36.87, m was 134 kilograms, times 0.5 meters per second squared. 134 kilograms times 9.81 meters per second squared plus 300 newtons sine of 36.87. And assuming that you can type this into your calculator correctly, you should get 0.11575, I think. Double check. Yeah. All right. That was number 13. Number 14 were like the two examples we were doing today. So you're pulling a box this time. It's a 92 kilogram box, and if you're pulling it, it means upward at an angle. So this will be your Fx, your Fy will be going up, so will your Fn, your Fg will be going down, your friction will be backwards. Across the floor, the angle is 60 degrees. Acceleration is 2 meters per second squared, and the coefficient is 0.3, and it wants to know what force you're pulling with. So again, start with sum of the forces in the y direction will be equal to MAY, so it'll be Fn plus Fy minus Fg equals 0. So Fn will equal mg minus F sine theta. Go to sum of the forces in the in the x. And in the x, there's Fx minus friction is equal to max. So that's F cos theta, minus mu Fn is equal to max. But now where Fn is, we're going to fill in this. So it'll be F cos theta minus mu brackets mg minus F sine theta. Close the brackets equals max. So you got an F stuck inside the bracket, so you need to multiply through to free it. So it'll be minus mu mg plus mu F sine theta is equal to max. You're solving for F, so bring your mu mg over. So F cos theta plus mu F sine theta will equal MAX plus mu MG. And now factor your F out. Cos theta plus mu sine theta. This side stays the same. Divide by the bracket. So F equals MAX plus mu MG over cos theta plus mu sine theta. And now fill in your values. So the M was 92 kilograms times 2 meters per second squared plus 0.3 times 92 kilograms times 9.81 meters per second squared divided by cos of 60, I think, yeah, minus 0.3 times the sine of 60. And again, if you can use your calculator, you should get a force of 598.5 newtons. All right, next, number 15. Box. This time we don't know the mass, but you're pushing with a force of 300 newtons, so pushing is downward. 300 newtons. This will be your Fx, this will be your Fy, downward at an angle of 30 degrees. This will be your Fg, this will be your Fn, this will be your friction. And it tells us the coefficient of friction is 0.255, whoops, second 5 in there, and it tells you the acceleration is 1.25 meters per second squared, and it wants to know what's the mass. So again, sum of the forces in the y direction will equal MAY, which is 0, so Fn minus Fg, and Fy is going down this time, so it's a negative. So Fn equals mg plus F sine theta. Okay, go to sum of the forces in the x direction, equal to MAX. So it'll be Fx minus friction is equal to MAX. So it'll be F cos theta minus mu Fn is equal to MAX. And now where the Fn is, we're going to sub this in. So it'll be F cos theta minus mu brackets mg plus F sine theta is equal to MAX. So now multiply through by the mu, and you get F cos theta minus mu mg minus mu F sine theta is equal to MAX. Take your mu mg over, so F cos theta minus mu F sine theta is equal to MAX plus mu mg. Factor out your F. It'll be cos theta minus mu sine theta, and now divide by it. So you'll have F equals MAX plus mu mg divided by cos theta minus mu sine theta. Oh shoot, I was solving for m. So on this side, factor your m out. AX plus mu mg, and now instead of dividing by that, divide the opposite way. So this will be m equals F cos theta minus mu F sine theta, it's good to stay awake, divided by AX plus mu g. And now fill your numbers in. Am I going to run out of time? Maybe. F was 300 newtons, cos of 30, minus 0.255, 300 newtons, sine of 30, divided by 1.25 meters per second squared plus 0.255 times 9.81 meters per second squared. Careful of your brackets on the bottom, and you should get 59, can't see, 0.06 kilograms when you do this. Okay? Look at that with moments to spare. 59.06 kgs. All right. And clearly it's the same steps, you just factor a different thing.